permits. Now I'd like to hand it over to Tony Monaco from Swanson, Martin & Bell, who will begin the presentation. Tony?
Thanks. Thanks everybody for joining. Really honored to get to be with this group, particularly as a moderator, because my job will be quite easy. I hope to bring some entertainment along the way, but we have a panel of just, really incredibly brilliant speakers and some really new cutting edge information for all of you today. One thing that we have learned, all of us, over the last year is that change is certain. And with change, we're going to have lawsuits. And so I think today is an opportunity for us all to take in some information about where things are, and really more importantly, where things are going to be going. Nobody has a crystal ball. We don't know exactly. But I hope to learn a little bit more from our speakers today, and I hope you do too. Just real briefly, I'm going to give you their name and company, and each speaker before their presentation will provide a little bit more information about themselves or their background as appropriate. But we have from RHP Risk Management, Ben Heckman, who is an industrial hygienist and occupational safety scientist. After that, you're going to hear from Susan Heinking with Pepper Construction. After Susan, you'll hear from Eric Malmstrom, the CEO of Safe Traces. And then finally, to bring it home, we have Megan Slominski, and she is with the manager of commercial lines with Crum and Forster. And so without further ado, I'm just going to sort of set the background a little backdrop before they get into their presentations. And by the way, my name is Tony Monaco. I'm with a law firm Swanson, Martin & Bell, based out of Chicago, and I have been the chair of multiple different practice groups, and I'm a partner at the firm. We want to just provide a little bit of data, and I show, of course, the tipping scales of justice and talk about lawyer advertising. One thing for certain, we've all been around the house more, watching a little more TV, at least I have been, especially when you see what's going on during the daytime, these daytime TV ads with lawyers advertising. The numbers are really astonishing. I don't have a breakdown of how much lawyer advertising has been going on specifically with regard to COVID claims, but it is going on and it's going to increase. Just some basic data that we were able to pull from some publicly available databases, that nationally, cases related to the COVID-19 crisis, there's over 5,000 of them have been filed in federal courts and over 1,500 of them in state courts just from March 1st last year up and through February 12th. The great majority of those cases reside in the area of employment law, disability leave, accommodation, discrimination, harassment, whistleblowing, retaliation, wage and hour claims. Those are by far and away the most voluminous cases that have been filed, but there are also premises liability, tort cases, unsafe work environment, and of course, workers' compensation that's on the rise as well. And then, of course, there's a whole nother set of commercial litigation, business-to-business litigation dealing with force majeure. I just cite you to In re Fritz. If you Google that, you'll find quite a bit about force majeure and how that is interpreted, but commercial frustration, and then, of course, the forcible entry, detainer, and eviction kind of litigation. Those are the majority of the cases, but we're going to see it really, I think it's touching every area and every practice group. Of course, being from Chicago and practicing in 3 of the most active judicial hellholes on a yearly basis that they've been named or dubbed, we always see quite a bit of litigation in Illinois. So far, we were able to calculate based on publicly available data that were 81 cases filed, 77 of them, of course, in my home of Cook County, and 4 cases in Sangamon County, which is down near around Springfield in central Illinois. They're kind of broken up there on the screen for you, but the point is the cases are coming. Now, I'm just going to reference you to the PrEP Act. I don't want to bore you. This can get pretty tedious. And to be honest, a partner of mine named Sarah Farrell has become sort of an expert in this area on behalf of our firm. And so some of this is her information that she helped provide me with. I've included several slides, but basically the PrEP Act is the Declaration under Public Readiness and Emergency Preparedness Act for medical countermeasures against COVID-19. It's important that you know about the act and generally what it is, but it is to provide immunity from lawsuits. And there have been a whole series of interpretations and discussions of the act. Not a lot of decisions from case law yet, but I am not going to spend a lot of time today, or really any time, other than these slides will be in the materials for you. You can reference these slides. But more importantly, I can get you in contact with my partner, Sarah Farrell, if necessary, who can walk you through any of these issues as far as the types of immunities that the PrEP Act can offer. And with that, I am going to turn it over, but it looks like we have a question. And I believe this is for CLE purposes.
Thanks, Tony.
And with that, Ben, why don't you take it away?
Sure. My name is Ben Heckman. I'm a principal and co-founder of RHP Risk Management, and we specialize in public health science and specifically occupational health and ventilation expertise. The title of this presentation is COVID-19, the State of Knowledge, What We Know and What We Don't Know. The background, I think, as most people are aware, there are three modes of transmission of COVID-19, which involves close contact, which is either directly touching or being within 6 feet of someone with COVID. Long range is aerosol transmission, which can have transmission that is greater than 6 feet, and the aerosols can remain airborne for a longer period of time. And then, and as well, there's fomite, which is the transmission of the virus from an inanimate object. The evidence continues to support the transmission via respiratory droplets and aerosol transmission, supporting the use of engineering controls and this presentation. Subject matter. In industrial hygiene, there are a hierarchy of controls, and that ranges from most effective to least effective. And that starts at the top. The most effective level is elimination, which is essentially social isolation as it relates to COVID. And then we have substitution, the next layer down, which is really difficult with COVID and not really applicable, obviously. The next level is engineering controls, which are physical barriers or ventilation. The next layer is administrative controls, which changes the way people do their work, basically work from home, staggering the workforce, even hand hygiene and other procedures. And the last level is personal protective equipment, which involves respirators, gloves, goggles, other things, and then as well as masking, which is more community personal protective equipment. The current guidance from the CDC and Ashrae recommends increasing the percentage of outdoor air. And essentially what that is encouraging is to increase the amount of outside air or clean air to your facility, as well as clean air would involve filtration of the relevant size particles for COVID. Also increasing total airflow to occupied spaces, disabling the demand control ventilation controls that reduce air supply based on temperature, improving air filtration to a MERV 13 rating or higher, and also considering the use of HEPA fan filtration. And there are obviously other methods that involve opening windows and doors, decreasing occupancy, modifying your fan controls to an on mode versus, or changing it to an on mode versus an automatic mode, and also generating clean to less clean air movement. And then also running the HVAC system for a maximum of 2 hours before and after your occupied building. Ventilation can be assessed to determine the effectiveness of your control measures. An important part of that is to verify, test, and validate the air changes per hour within your system. And again, essentially the air changes per hour it involves the amount of clean air or filtered air, and clean air involving outside air that is coming into the occupied space. And you can assess your HVAC particulate distribution, filtration, and particle removal efficiency as well to increase that amount of clean air changes per hour. And it's also important to evaluate against the current guidance from, for example, the CDC, the American Industrial Hygiene Association, and then Ashrae as well. Air changes per hour is a measurement of how many times the air within a defined space, usually measured in cubic feet, is replaced per hour. This can be measured through tracer gas studies, as well as calculated using building HVAC systems, depending on the sophistication of your system. And again, the air changes per hour is involving essentially clean air, which is a function of outside air for dilution, as well as filtered air for the appropriate size particle for COVID. This slide is representing a relative risk reduction that has been published by the AIHA, which is at the bottom of this slide. And it really shows the relative risk reduction of certain ventilation air change rates and how that relates to other measures such as respiratory protection or masking. And this involves increasing the outside air as you move towards more air changes and more effective controls, as well as potentially using, as I referenced earlier, the HEPA filtration or air filtration devices, which supplement your building ventilation system. It's important to realize that the 90% relative risk reduction shown in this diagram is the equivalent of wearing an N95 respirator. And so basically, if you have air changes of 4.5 air changes per hour, that would be equivalent to everyone wearing an N95 respirator within your facility for a relative risk reduction. This slide shows one example that has one outside air change per hour, which is clean air or outside air, plus in the green box, you have 5 devices that are providing each 1 air change per hour of filtered air, and those combined would equal 6 air changes per hour. So it's showing the increase with the air changes per hour of clean air and the filtration improvement to get you at 6 air changes per hour, which would be above the threshold that we just discussed earlier in the previous slide. It's important to evaluate your HVAC system with regards to the AIHA as a reference that I explained earlier, as well as to Ashrae guidance, for example. Ashrae has put out a building readiness guide for COVID in August of 2020, and in that they recommend maximizing the amount of outside air to your facility to the extent possible. And that guidance is qualitative, and I think it's important to reference this guide, which is also another Ashrae guidance, to understand what levels of fresh air or outside air were recommended for non-pandemic or pre-pandemic conditions. And that way you can evaluate the recommendations in the current guideline as to how well you're doing when you're looking at non-pandemic conditions. The HVAC controls for filtration, the fraction of particles that are removed from air is provided by the minimal efficiency removal value. And the MERV rating, Ashrae encourages building owners to improve their filter efficiency to at least MERV 13 or 14. The HEPA filter efficiency of HEPA filtration is better than MERV 16. And what this diagram or the chart on the right shows is the equivalent Ashrae MERV rating, 1 through 6, is equivalent to the ISO standard and their rating for an ISO course. And you move down the chart to the MERV 13 or 16, which is approaching HEPA filtration rating, and that's equivalent to the PM 1.0 for the ISO standard. So it shows sort of the 2 standards that are commonly found for the filter categorization. It's important to understand that there are controls and upgrades that you can use for your system which improve air purification. You can use standalone air filtration devices equipped with HEPA filters, as I mentioned earlier, which is better than the MERV rating of 16, as well as you can use, as recommended by Ashrae and the CDC, ultraviolet germicidal irradiation technology, which inactivates the pathogens without removing the virus. As well, you can monitor and look at temperature and humidity controls, and then also use local exhaust ventilation. Susan with Pepper Construction is going to go into more details about specific controls and upgrades based on her experience. It's important to verify your HVAC controls and solutions that you may be contemplating to putting in your system. And it's important, and those can involve visual inspections, evaluating system upgrades, using tracer gas testing to verify your building system is operating as you expect or hope, and then also utilizing surrogate particulates to improve the understanding and correlations between dilution ventilation and particulate filtration rates. And Eric Malmstrom with Safe Traces is going to go into detail more specifically about Safe Traces in Variedart, which is the first of its kind liquid aerosol that helps answer those two questions regarding dilution ventilation and particulate filtration rates. It's one solution that helps provide that. The overall benefits of taking steps to reduce risk of virus transmission are numerous, including reducing the risk of an outbreak, adverse publicity, and costly shutdowns, increasing employee and occupant confidence that a workplace is safe for return, improving productivity and maximizing profitability by optimizing operations within the current pandemic restrictions, reducing the risk of workers' comp claims from workplace exposure, and documenting implementation of best practices and defensible processes. In closing, it's important to stay informed as things have evolved very quickly during this pandemic with regulations, industry guidance. There's a range of sources that are providing guidance as well as best practices. For example, with the new administration that we were notified on January 21st that there is a pending federal OSHA emergency temporary standard for COVID. It has not been released within the 2 weeks. That would have put us sort of in the first week of February. But I believe there is guidance in the Code of Federal Regulations or the White House memo under the executive order that by March 15th, there will be an announcement regarding whether or not the emergency temporary standard for federal OSHA will be in place. And lastly, which I think is important, effective solutions should not be limited to a single control mechanism or practice. Instead, multiple control measures should be implemented to add layers of protection, such as social distancing, face coverings, personal hygiene, and engineering controls that all work together to reduce risk. And with that,
Ben,
yes.
Yeah, Ben,
Go ahead,
Tony. I was going to, and I didn't announce this, there's a box for the audience to put in questions, so they can feel free to add some questions. Generally speaking, I'll try to hold them to the end, but I think we can ask that there's one right now, and I don't know if you can answer this or if you can see it, but the question, oh, you got it? Let me ask the question, and then, because the audience may not see it, would the ACH on a passenger plane be the reason we haven't seen many transmitted cases on the airlines? I don't know if you can address that or not.
Yes, I can. So I've looked at the study, and I've been traveling given the need for ventilation assessments during COVID. And the study that was done for the airlines really addressed air changes per hour as well as HEPA filtration. So they have those two things that are incorporated. It's air changes per hour as well as filtration. And it's my understanding that, you know, the air is very good on the commercial airlines that I had traveled on, if that answers the question. It's a combination of the things that I had highlighted earlier.
All right, great. We are going to have some time at the end for questions, so I wanted to at least address one. I see a whole bunch more questions coming in now, but I think to keep this on track, let's go to Susan next, if we can. and then we'll try to come back to some questions at the end.
Thanks, Tony. And just to remind everybody, they need to do that question that just popped up after my presentation for the CLE points.
Great.
Thank you so much. Hi, I am Susan Heinking. I am with Pepper Construction. We are based in Chicago and in the suburbs in Barrington. We have offices in Milwaukee, in Wisconsin, Indianapolis, Indiana, and then 2 offices in Ohio, Columbus, and Cincinnati. So we're Midwest-based construction firm. And my job at Pepper is to lead our high-performance and sustainable construction group. And what that means is really looking at building performance with a lens on sustainability and healthy interiors. So my background is architecture. I'm a licensed architect in Illinois, but I've been in the construction side of the industry for about 6 years now. So I've gotten to know both kind of sides of how buildings get designed and then how they actually get built. And then in addition to that, a lot of contractors get called in for maybe maintenance issues of a building. So really working with building operators to understand how to run their buildings and how their mechanical systems work over time and how to tweak them to make them better. So looking at this pandemic and COVID, it's an ever evolving situation. We are having a lot of recommendations from the CDC and from different agencies of what is a highly contagious type of situation to like the best case scenario to reduce our risks. The one most lately being 6 feet apart, double masking with the new variants that are out that have been deemed more contagious. So as we've kind of gone along this past year in the building industry, we've also had to be flexible and pivot and realign with what works, maybe what doesn't work, and really try to help our clients understand their buildings and how to run them, and then what types of layers of strategies they can take to be as healthy and safe as possible. Sorry. But as Ben said on his last slide, there's not a silver bullet. Like there's just like layers of strategies that you need to be putting in place before we can really tackle the problem. So we call that the Swiss cheese model. So a block of Swiss cheese is pretty solid, but when you cut it up, it's just layers of voids. But when you put them together, you've got a pretty solid solution. So I just want to really start off my segment of the presentation by saying, there's not a one-size-fits-all solution. Every building's different. And that when we talk about indoor air quality and building performance, that is in addition to all of the other things that we need to do on our own personal behavior, like wearing a face mask, social distancing, cleaning, and hand washing. So OSHA, that's kind of where contractors fall to, understanding like what do we need to do? We do not want to go above and beyond OSHA. That is going to create additional risk for us. So this is our guidebook. This is where we kind of draw the line. We're never going to adopt anything higher than that, because if we do, we run the risk of lawsuits. Because if we say, okay, well, we're going to be X amount better than OSHA, and we actually fail, then we're going to be held liable and we could get sued. So we really look to OSHA to tell us what we should be doing. But when this pandemic hit, a lot of our clients called us to say, what can we do to make our buildings healthier, because everybody was working from home, and a lot of building owners want to get people back into their buildings because they were having a huge hit from all of those vacancies. And so a lot of it looking at kind of what the AIA was doing, LEED, which is a green building rating system, WELL, which is another one, already had certain guidelines in place to improve indoor air quality, but it wasn't like for a pandemic per se. It was really looking at Improving indoor air quality led to higher productivity rates, cognitive function, less sick days, but not sick days because of COVID, but 6 days because somebody had a cold. And so, a lot of people kind of started off there with, okay, what can we do? And the AIA, which is the American Institute of Architects, which is the architecture group, the national group, created a re-occupancy assessment tool that architects could work with owners to get their tenants back into their buildings. And it follows that hierarchy triangle that Ben had showed before, looking at elimination, substitution, what are your building engineer controls, your administrative controls, and then your PPE. And so looking at your engineering controls, that's kind of where the contractors can come in and really kind of help look at, okay, what is your mechanical system? Because not every single mechanical system is created equal. As Ben had mentioned, you can increase your air, but not every mechanical system, not every building is actually set up that you are actually able to do that. So in your house, for example, you probably have forced air, let's say, but that's just recirculating the air that's already inside your house. To increase your fresh air through your house, you would have to actually physically open your windows or open your door. No one's going to do that this past week with the polar vortex setting in. So these are like certain things that you would have to know as a building owner of like, okay, what is my system and actually how does it perform and how does it act and what can I do? So the AIA has kind of gone through and looked at, okay, what can we do to kind of help guide people through getting people back into buildings. LEED, which is a third-party green building rating system. So in Chicago, if you're walking downtown, you'll see a lot of these LEED plaques. I'll say like LEED Gold or LEED Silver. And what that means is that it's a green building. They created a special credit with regards to COVID-19 for any sort of space that was going after certification. It literally says if you follow the AIA reentry to the workforce plan, then you will get a credit. But then it's also asking the building managers to do like daily journal entries of, what went well, what didn't go well. Because again, there is no silver bullet here. We're all, we're a year in and we're all still trying to figure this out. We're getting closer. We're closer than we were last year. But again, because this virus keeps changing, we also have to kind of keep changing along with it. But then we also have to be conscious as contractors and even as architects that this is going beyond what our codes are telling us to do. This is saying, okay, you're going to do better than code. You're going to do more than maybe what OSHA is telling you to do. So we have to really toe the line carefully on, kind of with our clarifications of, saying, here's the guidebook that we're going to be at. And then, here's the extra that we don't want to be liable for. So WELL is another third building rating system. It's the newest one in the market. It was developed with Cleveland Clinic in Mayo. And so WELL really bases themselves on creating healthy interiors. There's a lot of evidence-based solutions within the WELL guidebook that you would design and build a hospital under, not necessarily an office. And so they have created the WELL Health Safety Seal. And they're really marketing this as, all right, you are COVID ready, you're safe, you're secure, you can call it good. Personally, that makes me nervous just because, again, it's not all the way proven out, but that's just how they're marketing it. But again, they're going through cleaning and sanitizing, emergency preparation, health and service resources, air and water quality management. That's where they are testing the air on a regular basis, testing the water on a regular basis. What is that engagement? and communication with the building owners and the people inside, and any sort of innovation strategies that might pop up as we kind of go along in time with this pandemic that's going to turn into an endemic, in what they can apply and adapt into this health safety rated seal. So this isn't necessarily saying like I'm a well-certified building. This is a special pathway that they are putting out there in the market to follow. So we, in the material that's going to be provided to you, is going to be a white paper that Pepper wrote along with our MEP, our mechanical, electrical, plumbing coordinators that work with mechanical systems on a daily basis. And what we did is, when all of the mechanical systems and strategies started coming to the marketplace, we started to kind of score them on effectiveness. And so this is kind of like that timeline of like least effective, or, try to avoid in red, to most effective. And so a lot of it had to do with that fresh air, but not only that fresh air, but with humidity levels. And so looking at that, you really have to understand how a building works and how a building's envelope or the walls of the roof really correlate with those mechanical systems, because humidity, while it can really be a positive for virus transmission between that 40 and 60%, that humidity, if it rises above 60%, and you're getting into that 80% zone, now you've got mold and mildew problems. So it's really important that you are engaging the proper experts to make sure that you're finding that right balance. So we looked at different systems. So I said before, humidity is super important, but so is fresh air, which Ben covered. But we also looked at CO2 levels. So in order to know if you're, Ben said like you need to measure how much fresh air you have. In order to know if you have enough fresh air, you measure that by your CO2. So as I'm speaking to you right now, like we all exhale CO2. And so what happens is you can set these CO2 sensors, and they're not very expensive. You can just buy them, at Home Depot, and you can set them at a certain level. When the CO2 sensors like notice that certain level, it knows that it tells the mechanical system, hey, you need to bring in more fresh air because the CO2 level is getting too high. So that's a very simple way that we can monitor how much fresh air we're bringing into the building. Then you kind of get into those more advanced scenarios like the UVC. When UVC is used for disinfectant, it's called UVGI. Those are those UVC lights, and then bipolar ionization. So I'm going to talk about these two things next. So the UV, there's really great potential with UV. It does, when you have UVC, it does disinfect surfaces. When you put it in a mechanical system like this, you can kind of see that it's coming through the filter, the UV light is in there, so it's disinfecting whatever air or particles, particulate matter that are coming through, and then the ductwork, it's grabbing it. Again, the problem with UVC is that it has to be installed properly. So you have to be very careful about that. It can contain mercury, so you need to know what light bulb you're actually buying. So you want to make sure that it's row house certified or accredited. It has to be, you have to make sure that, it has a UL rating to it. If it does, then it's safe to be put in your mechanical system, because you have to hit a certain wavelength on the UVC lamp. So it's not harmful to anybody that is providing maintenance, or, it can actually burn your skin if you're exposed to it for too long. And it is regulated by the FDA. So while it does do the job, there's a lot of caveats on the end that in order to do its job, it's got to be operated properly and installed properly. Same thing with bipolar ionization. So there's a, there's a mechanical or an electrical unit that you can insert into your ductwork or in your mechanical system itself, something that's providing air. So this does not work for any sort of radiant system. If you go to a hotel and you see those, they're called PTAC units in the wall, right underneath the window, and they're super loud and annoying. It doesn't work for those, but it does work. Like if you have forced air, you can put these units in, and they basically create ions, negative and positive ions. So ions are actually found in fresh air, no doubt, in nature. And what it does is that you can think of it as neutralizing the air. And it kind of creates like a magnetic field where it's attaching itself to different particles in the air. And so they kind of start to magnetize together and they start to kind of grow, and they become bigger particles. And why that's a good thing is because the bigger the particle is, the better the filter can actually capture it. Now, another benefit to these bipolar ionization devices is that with viruses such as COVID-19, is that it can attach to the protein level of the virus, rendering it inactive. So that is really great news if you did have a virus floating in the air in your space. But again, bipolar ionization it's expensive. It's not for every single mechanical system out there. So you can't just say, oh, I have a bipolar ionization device, I'm good. It really depends on what your mechanical system is in this space. So these are pictures of what a bipolar ionization device looks like. So it's all the blue. So just look for the blue. So right here, you can see there's a track, and then these little nodules is where the electrodes are being generated. Here, it's on the side next to the fan. This is the filter. And right here, it's on the side. So you also would need to have an electrician or a mechanical contractor that knows how to install these devices. If you're looking at like large commercial spaces, you can buy them for your like furnace at home, and it's pretty simple to install. But again, you would need to know what model you're buying for. This one is a bipolar ionization, and you can see that this is a duct, and you can see that you can cut a hole in the ductwork and like slide it right in. So this is another option. We are doing studies in our Barrington office. This is a picture of our Barrington office right now. So when the pandemic hit, we were like, what do we do? Right? Just like everybody else, what do we do? And we were like, okay, well, we got to increase fresh air. And because of the rooftop units that we have, we were able to do that. Now, we were only able to do that by so much because our units are a little old. But we said, okay, we need to upgrade our filtration to MERV 13 because we had MERV 8, and we need to increase our fresh air. So we knew we needed to do that, and then we installed CO2 sensors to make sure that we were giving enough fresh air to everybody. Then we learned about bipolar ionization, and we said, let's check this out. Everyone's asking about it. We might as well study it in our own space. So we installed the bipolar ionization, and you can see like right now, these little devices that you can see here are measuring how much ions are being generated in the air. And so when you do that, you want to make sure that, when you do that, you want to make sure that you have the right software and the right devices to do. It's not like this is part of every building. You would have to hire a special consultant to measure that. But what we found was that the air quality was already doing so well just by increasing the fresh air in the MERV 13 filters. When we tested the ions, we saw that the only change was decreasing the ultrafine particles in half. So now we're going to go back and say, all right, can we take it back down to a MERV 8 from a MERV 13 and still get the same result, because MERV 13s are expensive. And obviously, as a building owner, we want to make sure that we are, saving as much operational dollars as we can. So when we look, everyone's like, okay, well, how is building design going to change? Well, we're going to be looking at a floor by floor, probably mechanical solution from here on out when you kind of talk about new construction. Before, it was a central system where everybody kind of shared the same type of air. I don't think that's going to be able, to happen anymore. So we're going to look at we're going to have a lot more conversations about floor by floor. And that's called displacement ventilation. When you look at a displacement ventilation, you're looking at air coming up from the floor and then dispersing up into the air. So that makes sense because we as human beings are closer to the floor than we are in the ceiling. So we want to supply low, and so that we're like all breathing the cleanest air we can, and then return high. So any sort of polluted air goes away and gets exhausted to the outdoors. But this is going to have some additional cost to it for buildings going forward, because now our floor to floor height, where maybe it was 10 foot, each floor was like 10 foot pre-pandemic, because of this solution, it might be 12 foot per pandemic. So now you've got taller floor to floor heights, which means you're going to have more material. And when you have a floor to floor type of solution like that, rather than a centralized system, you're going to have more costs in regards to mechanical and electrical runs. So here's another kind of diagram of when I say supply low from underneath the floor. So you have all this clean air, and then, return high. So in conclusion, just to keep in mind, one, there's not one size fits all solution. It's not that simple. If you can do anything, ventilate, at your house, open your windows for 30 minutes a day for as long as you can take it. If that's the way to get fresh air into the building or into your home, it works. Filtration, get the highest MERV rating that you can afford. Air distribution, understand kind of where the air is coming from, like where's the supply and then where's the return. Relative humidity, so 40 to 60%, that's our sweet spot. But again, that has to be balanced out with the architecture of the building, because we don't want any mold or mildew issues. And then thirdly, disinfection. So how can we clean that air? You can kind of think of that bipolar ionization as part of that, is being able to kind of disinfect any sort of viral proteins, or clumping more particulates together so the filter can capture them better. And with that,
Susan, thanks so much. That's great. Very nice. We do have a whole series of questions, but I think it's best for Susan to have an opportunity to kind of browse them now that she's done speaking, and we'll come back to some of those questions if we can when we're wrapping up. So with that, Eric, why don't you take it over from here? Thanks so much, Susan.
Yeah, thanks so much, and thanks everyone for the opportunity to speak today. So I think the previous speakers did a great job kind of laying out the legal landscape, the kind of how to think about the safety controls, both from an industrial hygiene and a kind of building and mechanical perspective. And that kind of dumps out into what I'm going to talk about, which is what technologies and tools are available to help guide decisions at the front end, and then after you've implemented a plan to verify how well it's actually working with science and data. So just by way of brief background, so I'm the CEO of Safe Traces. Safe Traces is a Bay Area-based technology company that focuses on DNA-based diagnostic solutions. We were founded about 5 years ago, and we actually our technology was developed in the national labs in the wake of September 11th, and heightened concerns about bioterror, biosecurity risks facing the country, and specifically things like anthrax spores. And the government had a desire to create safe materials that could mimic the mobility and exposure of airborne pathogens. And so our company and the technology was spun out of that kind of background. And over the subsequent years, we've advanced the technology pretty significantly. And I guess just in terms of quick background on the company, we have a small team of about 15 folks who are primarily scientists, so microbiologists, chemists. Then we also have a mechanical and software engineering team, people with frontline kind of safety practitioner experience, and then our commercial business team. We partner with a number of leading research institutions, both on the kind of government side and groups like the National Institutes of Health, FDA, NSF. And then we also partner with leading research institutions and individuals there at places like Stanford, MIT. We also have great investors, technical advisors, and commercial partners. So our suite of technologies covers air quality, food and pharmaceutical traceability, and sanitation verification. The focus today will be on the air quality side, and specifically how you can use our tech to verify your ventilation and filtration controls. So to just kind of set things up, and some of these slides I'm going to breeze through because the previous speakers have already kind of covered this pretty comprehensively. But, you know, the big question facing us all right now is how do we reopen safely? And some places have been open over the duration of the pandemic. Some are kind of at the precipice of trying to bring people back in. Some have done phased reintroductions of people back into their buildings. But the big kind of challenge facing us is airborne transmission. And I think that early on in the pandemic, this was not broadly understood, accepted, reflected in guidance. And so I'm an Army vet, and I like to use the analogy that we're really fighting an air war right now. I mean, there's definitely other kind of surface or ground components to what we're doing and needing to sanitize surfaces and so forth. But really you have to control the airspace in buildings because the virus is airborne. So we now understand, and I'd say there's consensus within the scientific and medical community that SARS-CoV-2 or the COVID-19 virus is transmitted through the air, and the indoor environments are much riskier, and the infection risk is much greater indoors than it is outdoors. And the high risk factors within buildings falls into three main categories, and these are from OSHA and the CDC: enclosed spaces, prolonged exposure, and spaces with inadequate ventilation. So Ben talked about this extensively before, and so I won't belabor this, but the key to the game from a risk mitigation standpoint is ventilation and filtration. The American Industrial Hygiene Association has been adamant about this in some of its guidance documents, and Ben talked through the kind of relative risk reduction benefit of bringing in more fresh air through air changes or through a combination of air changes plus filtration. You know, at relatively modest levels, it's providing the equivalent risk reduction benefit of N95 respirators and significantly more than face coverings and other PPE or administrative controls. So I think the real message here is that ventilation filtration is really critical to mitigating and reducing occupational health and safety risk. The challenge is that in terms of understanding what is appropriate for a specific building, and even within a building, given the dynamic nature of airflow and risk, what is going to be the way that you actually understand what is appropriate for my building and what's going to be appropriate in the winter versus the summer, or when we have 10% occupancy versus 50%. And I think that it's safe to say that the pandemic has exposed real limitations in the toolbox of people responsible for assessing risk and making decisions. And I won't go too much in detail in this table, but I've listed out some of the tools that people are using right now to understand risk. Before you understand, then, well, here are the things that we need to do within the space to keep people safe. But you have, I think, two categories of solutions out there, or diagnostic solutions. One falls in the category of what I'll call quantitatively rigorous but theoretical. And so things like computational fluid dynamic modeling and math calculations, and notably the Wells-Riley calculation, which is commonly used to assess infection control and infection risk for airborne viruses. Those are great theoretical tools, but they are not in real world spaces, and they're theoretical. And so really what they lack, I think, is what is going on in an actual real world environment. And then they're kind of giving you a piece of the story, but not giving you the full story of how things are moving around and what the risk looks like. You also have more applied tools like tracer gas, sensors and monitors, which are not oriented specifically towards airborne pathogens, but it's other air quality types of concerns like carbon monoxide, carbon dioxide, VOCs. And those are great in that they are real world tools, but they're also giving you an incomplete picture of how are viral particles that are airborne, moving around and creating risk. And then finally, you have actual COVID tests, both for air and surface. And I guess there you're actually testing for the pathogen. However, they're kind of not, one, they're expensive. Number two, the efficacy of these tests is a little bit debatable. And number three, in some ways you can think of them as lagging indicators, because you get a positive, and then there's the question of how did the virus actually get to a specific spot, whether it's a surface or in the air. Was the virus still viable at that point? There are lots of questions, and you in some ways the positives are raising more questions than they're answering at times. And so I guess to summarize, there's a lack of effective, cost-effective solutions for assessing real-world exposure risk, and then guiding the decision-making process of what is the right ventilation rate or the air exchange rate within a building, or what's the right filtration level that we need, and all those types of brass tacks questions that everyone is facing right now as they're making those decisions on the merits of the health and safety benefit that each of those things provides, but also importantly, the financial consequences of those decisions. And if you do everything that's recommended, the price tag starts getting pretty significant pretty quickly. And so you have to be much more, I think, surgical and targeted about what you need to do. And that's kind of where we saw a gap and a big opportunity. So we offer a solution called Variedart, which is the first and only solution for verifying ventilation and filtration efficacy specifically for airborne pathogens. We do that through kind of two main elements of our technology. The first is through what we call the front end side of things, or the actual tracer particles. So we've developed DNA tag tracer particles that mimic respiratory aerosol mobility and exposure. And so it's using safe materials. So we're using water soluble food grade materials. So it's a combination of distilled water, DNA, and then a DNA carrier. All the materials are FDA generally recognized as safe, and they're being used at levels well below the OSHA and NIOSH safe exposure levels for the relevant materials that we're using. But basically, you can think about this as a kind of fake sneeze or cough or some type of respiratory aerosol that's emitted by an infected person. And then the DNA tag allows us to track where those particles are moving within the facility. So you can release them in an office or in a conference room or in a lobby, and that's mimicking an infected person shedding virus. The DNA tag then allows us to sample throughout the building to see where they're being picked up, at what level. We can use different DNA sequences for each of the tracers that we release. And so when you go and sample, you're testing against multiple tracers simultaneously and developing a very kind of granular understanding of how particles are moving through the air. And importantly, the so what of that, of what do you do about it? How does that guide your decision-making process? And so the back-end technology really gets to that so what of we have a very visual, easy to understand way of where things are moving around, where they're creating a potential exposure risk based on how strongly the DNA signal is being picked up. And so the value of this is you're kind of taking the best of both worlds of the quantitative theoretical approaches and then the qualitative applied approaches in providing a quantitatively rigorous applied approach in a building to then get to, where's risk likely to be within a building and then how effective are various controls. So the three main tests that we offer are a dilution test, which is essentially asking the question within a room or a localized space, how long does it take for that room to clear and how impactful are various controls at accelerating the removal of the particles or the contaminants from the air. The second test that we offer is a filter challenge test. So the filter levels are developed off of solid particle testing, and we provide a liquid aerosol indication for how well those filters are actually performing, which is critical. And so this is serving both an audit function of filters within the building and then informing, do we need to change filters out? Do we need to upgrade from one MERV level to the next? And then even for something that's very popular right now, things like standalone HEPA units, which people are using in high-risk areas to kind of complement and supplement what's possible through the HVAC system. We can help test those as well to figure out where you want to place those, what setting levels, all that kind of stuff. Finally, we offer a survey test, which is kind of where we take a floor or a building or a large space, and we're simultaneously releasing tracers mimicking an infection event or someone shedding virus, and then we sample throughout the space to map the airflows, identify hotspots, and all that type of stuff. So, practically, how this is deployed is we work with certified EHS and industrial hygiene consultants, and RHP is a great partner with this respect. We also work with the mechanical engineering and plumbing community and HVAC contractors, and even beyond with indoor air quality experts who are trained on how to use the technology and then work with the end customers, so the owners and occupants of buildings, to develop an appropriate test plan, which is determined by what kind of questions they're trying to answer and risks they're trying to mitigate, the size and dimensions of the space, the HVAC system setup, and that will guide how we think about what's the appropriate test type, and then what are we specifically going to do, and what scenarios are we going to craft. And then once that's established, then a team goes on site, the certified partner goes on site, executes the test plan, which involves releasing the tracers in the space, allowing them to circulate, sampling, and then the samples are sent back to either our lab or through a partner lab, and we're working with SGS Galson, a leader in environmental monitoring solutions and industrial hygiene solutions. We basically run the samples through a PCR test to read the DNA, and then the DNA PCR results are then feeding kind of the data visualizations and analytics that are provided to the end customers in the final report to then ultimately guide decision making and use science, data, and technology to inform that. Just looking at time here, some of this. So, essentially, we can provide baseline assessments, and then commonly how we're used is you baseline the risk within a space, and then you make some changes either through a scenario test or actually doing remediation work, and then we come back and we do a follow-up test to see how effective those controls were. Notably, kind of who we're working with now, I mean, we're working with everyone from owner-operator facilities to big commercial real estate owners, notably the Irvine Company, who is a large commercial real estate owner. And they used us to basically verify efficacy of their HVAC controls in both office and residential properties. And then they used the data both for the kind of concrete engineering and facility management side of things, but then they incorporated the data into a national campaign called Come Back with Confidence to explain what they're doing to keep their tenants and occupants safe, and using us as a way to say we've used kind of leading technology and third-party validation to confirm that. So some of this, I mean, just to give you a sense, the pre-post testing, we'll release a tracer, and you can see this. It's kind of hard to see in this graphic, but there's a dark red dot. We released a tracer in a kitchen, in an office space, and then we sample against all these different points within the building, and we get a measurement of how significant the DNA signal is at those spots. And so we test that under pre-COVID settings and then COVID settings. And basically, more green is showing that we're getting kind of trace levels of the tracers picked up at spots. And so what this is telling you is, kind of looking broadly at this, you're seeing more green under the COVID settings than the pre-COVID settings. And so you're seeing some empirical validation that the settings are actually working well. And in this case, it was bringing more fresh air and implementing higher filtration levels in the facility. Additionally, we kind of scenario test, filtration levels. So what benefit am I getting from MERV 8 to MERV 13, or both of those MERV levels in the HVAC system plus a portable HEPA unit? And so we have these relative decay curves, which show very quantitatively how impactful those different controls are at removing particles from the air. And in this case, the kind of punchline was that we were informing the decision from a large Fortune 50 company that was making a corporate-wide kind of decision on whether they're going to invest in MERV level upgrades, standalone HEPA units, or both. And we were showing in our data that the standalone HEPA units were showing a very significant acceleration of the contaminants out of the air, whereas the MERV levels, it was a little bit less clear. And so this directly informed kind of a very financially consequential decision, and then also, from a health and safety standpoint, it was directly impacting kind of the employees in their facilities and keeping them safe and healthy and working and productive. I'm just going to skip over this stuff because I think I'm already over my time, but we can test airflow isolation between spaces.
You've got time. You've got time. We're doing fine.
Oh, okay. Well, another thing to call out is this is especially relevant for, say, hospitals and healthcare facilities where they already have pretty rigorous infection control protocol and systems in place, which involve not only filtration and ventilation, but also positive and negative pressure controls. And basically, you want to take areas where there are infected people within these facilities, and they're known to be infected, and contain air within that space and not have it, leak out into other areas where you don't have infected people, or you're trying to limit that risk. And so we've been working with healthcare hospital facilities, also the prison systems in several areas, and where they've had super spreader events, and they've been forced to kind of take people out of main prison blocks and create makeshift infection wards in abandoned buildings and otherwise, and kind of rig up a makeshift infection ward. And so what we did was over the summer, we worked with a prison going through a very difficult period where they had infection spreading amongst the inmate population, but then amongst the administrative and medical staff. And so they used an abandoned building as an infection ward. And you can see in this graphic here, the red area was where they had hundreds of infected patients or inmates. And then in the blue area in the kind of bottom right, that was where they were staging the administrative and medical staff. And they wanted to basically understand that air was not moving between the hot zone to the safe zone. And so we released tracers in the hot zone, and then we're measuring within the hot zone how significantly were they being detected. And then we were testing in the safe area to see that the air was not really traveling there, to try to confirm that. And we did this iteratively, so that initially, there was some air moving between the areas, but then they made changes, we retested, and we did it again. And gradually we got to the point where the pressure controls were working very well, and you were ultimately helping protect people, and they were hemorrhaging staff at that point. So, unfortunately, we've kind of had some issues with ICUs being at capacity, and non-standard kind of facilities are being set up for infection control. So, this is really popular right now, and all these case studies are intended to give you a sense of the range of applications and things that we're being called in to do. Right now, we are active in a variety of different areas, from school reopening to hospitals wanting to test their systems to mass transit. And we just worked with RHP on one of the largest mass transit systems in the entire country to help test rail cars and trying to get ridership back into the public transportation system. We're also testing office buildings. We're doing industrial kind of plant type testing as well. And really the big three buckets that we're being used for are, best practice kind of verification, validation. Increasingly, with all the OSHA updates that were mentioned previously, seems like there's going to be a much more significant kind of compliance responsibility on building owners and operators. And so we're paying close attention to that, but we become a verification layer in providing data to help support kind of compliance and provide documentation of that. And then finally, we're actively looking at how we incorporate into other certifications, some of which were mentioned earlier, things like WELL and LEED and their private offerings as well. And so I think our technology is very complementary to a lot of those other certifications. And so, we're actively exploring those opportunities as well. So I guess to summarize, technology is really evolving quickly, and as is the case when there are major crises or things that spur innovation. And the pandemic is no different right now, just given that the virus is airborne and that ventilation and filtration plays such a critical role in reducing risk. People know that, but now we need to get kind of more empirical and smarter in terms of what we're doing in real world spaces. And we really try to be a tool in that fight. And we're working, across different communities in terms of partnerships and with customers. I think that as it relates to this discussion, there's been a lot of interest within the insurance community and other regulators and kind of people working in the regulatory world for what we're doing, because it really just, can really support compliance and enforcement and so forth. So we're grateful for the opportunity to speak. You see my contact information up here, and welcome questions and also follow-ups coming out of this call. So thanks so much.
Thanks, Eric. That's great. And there are a series of questions. It sounds like most of the folks asking questions are asking technical questions, not legal questions. So if you can take a look at those, we'll come to it. And there's a question here on the screen, if everyone could answer that. And we're next going to come to Megan Slominski. And so Megan, being a trial lawyer, hearing all of this and the technologies available, and I just can imagine in 2 years from now, standing in front of a jury trying to explain why my client didn't use all of these best efforts and technologies, and having an insurance company wanting to explain why they're not liable for, what in no joke is very horrific, it could be tragic problems and death. And so let's talk a little bit about the insurance industry, and with all of this going on, if you could take it away.
Sure. Thanks, everybody. Just really grateful for the opportunity to be here. I'm a commercial claims director for Crown Forester. I manage the claims on the commercial side of the house that involve auto bodily injury, general liability, professional liability, such as assisted living, nursing homes, and see everything from a premises slip and fall to a propane explosion. So I manage adjusters all over the country, and in all 50 states, we have claims and they're in litigation or out of litigation. So this topic is near and dear to my heart, especially in the assisted living facility world, because that was really where everything was ramping up in the beginning. As you said before, Tony, the good defense for any carrier or for any attorney is risk management. And at Crum and Forrester in particular, I can't speak to other carriers, but I know that we really value that collaboration with our risk management department and also with our underwriters. When we have good risks that are implementing strategies and not just implementing them, but actually carrying them out and then documenting how they've carried those out. That really goes a long way to the defense of our case, whether it's a week from now or 2 years from now when we start to see litigation ramping up. So I, for all of you that like slides, I'm sorry, I only have one. I'm more of a talker, and this is intended to be more conversational. So I'm just going to talk about some of the trends that we're seeing in the insurance world since COVID hit, and then what those trends might look like in the future, how we're handling them right now, and I'll get more into the weeds on some specific lines of business like auto, GL, property, and so forth, and then what that's going to look like in the future. As we all know, premium has taken a huge hit in the insurance world. Back in May of last year, Lloyd's of London had released a statement estimating that the industry hit to underwriting premium globally on the industry front of insurance was going to be around $100 billion. So there's a number of reasons that that's happening. People's way of life has changed. This pandemic has changed the way we work, the way we live, and companies like Crum or like some of our insureds or some of you that are on this call right now, I think when all this started, we were forced right to our homes, and the work from home environment has become much more prevalent. So what does that mean from a risk standpoint or from an insurance standpoint? That means that people are working from home, so they're not driving as much. They're not frequenting their local restaurants as much on their lunch break when they would be in their office. They're not in that office space. So commercial real estate is going to have a decline. The restaurants are closing. So when we see this trickle down effect and the impact that's been on the businesses that were much more frequent before COVID, they're not there anymore. They don't need insurance. So just right there, that decline is affecting the premium grab in the insurance world. When people were polled in a random survey, 47% of people filed a claim, an auto or property claim last year, and 39% of them did it through a mobile app. So with the moving away from going to a brick and mortar type building for your needs or your goods, relying on Amazon, working from home, we're also going to see a surge in the insurance world for a digital environment. So 39% of those people filed their claim with a mobile app. And I think if that was just what it was last year and it's been successful, and that's something that is going to be a trend for 2021 for sure. We're going to see a digital surge in the insurance world. What that can create, though, is another risk. When you avoid one, you make another, right? So I think with that, we're going to see a surge, too, in cyber risk and cybersecurity breaches. As we move into this digital world and technology comes to the forefront, that could be a problem, and that could be something that we're going to see down the line. The people that are using the digital technology in the insurance world, filing their claims, submitting their pictures, and so forth, they're relying on the carrier and trusting the carrier that their information is protected and it's safe and it's not going anywhere else. And so when that exchange is happening, cyber risk is always a threat. And I think that we're going to see more of a surge in those type of claims, and that kind of written, like that's where premium might actually be coming in the door, is writing those cyber risk policies. So that's a little bit of the global trend for insurance. When we talk about auto, of course, the first 6 months of the COVID situation, driving was down 16.5% across the board. Places like New York City saw a decline from January to April of 93%. 93% less people driving in New York. And if you've ever been to New York, that was probably a dream because traffic there is horrible. There were 302 less fatalities. So all of this sounds good on paper. Less driving, less risk. What we saw, though, in the third quarter, when things started to ramp up again and open up and some of the restrictions were loosened there, the driving went up 13%. So there was a surge in driving. The surge in driving was also met with less law enforcement on the road, less inhibitions. I venture to say everyone on this call probably drank more in 2020 than they have before. So there's higher risk there with just bad decisions with the people that were on the road with that surge of that 13%. They did a study of people in the hospital that were in for serious injuries in 2020, and it was up 15%. That those people that had those serious injuries had drugs or alcohol in their system. So it's also supported by data. Less seatbelt usage, speeding was up, road rage was up, people were on edge. So just multiple factors from a human perspective that played into those accidents. So while driving was down, the severity of accidents was still present. So we are going to be seeing those auto claims still coming in the door. As far as GL is concerned, GL and professional liability, I think we're going to see a surge in litigation around those policies, practices, and procedures. As Tony said in the beginning, we're seeing the commercials on TV, and before COVID, you saw them probably for mesothelioma or asbestos exposure and things like that, where people have long-term effects or illness that is surrounding a workplace-related injury. I think in the next 2 or 3 years, you're going to start seeing the commercials as well, advertising for COVID exposure, whether it's in a nursing home or in a workplace situation, or just in general, if you were exposed at an amusement park, at a restaurant. And everything we've been talking about today as far as the risk management measures that you can take as an owner, I think go a long way to show that you took the proper precautions, you followed the CDC guidelines, you did everything you could. And those will ultimately be some of our defenses that we'll get into in a minute as well. As far as property is concerned, so first party property along the commercial lines, huge surge in business interruption claims. Of course, naturally, all of these businesses that had to close down and were forced to shut down through executive orders are wanting to claim business income. And so we had a huge uptick of those type of claims that were reported. When it comes to those type of claims, most commercial policies do have a virus exclusion, and that originates from the SARS event back in 2003. And most of those had those on the policy, and those are enforceable. So unfortunately, those type of claims have been denied. If they don't have the virus exclusion, another option from a carrier's perspective is that there wasn't a covered cause of loss through physical damage to trigger the business interruption. So that's the language that's in the policy that's also being used. I don't want to say that both of those are a slam dunk for a carrier when it comes to a coverage position that they might be, utilizing when it comes to these claims, but they have been pretty successful in the courts so far. There have been a few success stories on the other side for the business owners where their counsel is attacking ambiguity in the language of the contract. When that happens, generally a court will favor with the insured when it comes to ambiguity on the wording of the contract. I don't have work comp in here, but I think it's important to note work comp covers the occupational diseases in the course and scope, ordinary diseases of life. This would include COVID. What's interesting, so far a statistic I found, 2% of the COVID work comp cases that were filed in 2020 resulted in permanent or temporary permanent disability. So while a 2% isn't necessarily a huge influx of claims or a huge amount there, I think it does show that there could be some value to these claims and something to think about in the work comp arena. We're also going to see a litigation backlog. Of course, closed with all the businesses were the courts. So Tony can probably speak to this better than myself, but with courts not operating for X amount of months, the backlog that has now been created is going to push cases into 2022, if not 2023 in some jurisdictions. So there's been a lot of hold on discovery. There's been holds on motions that would ultimately dispose a case in some places. And I think that backlog is going to be something that you're going to have to prepare for as a carrier when it comes to the life of the file, the expenses for the file, and how you plan on ultimately resolving it. Because of the litigation backlog, we've seen an uptick in time-limited and policy-limited demands. So with that, with the courts closed and no opportunity for a runaway jury verdict that we're seeing in some states like Georgia, California, Florida, Texas, where there's these, I call it monopoly money, but just multi-million-dollar verdicts, those haven't been happening because there haven't been trials. And so the only way that these cases can resolve for those big dollars sometimes is when the opposing counsel are making these time-limited demands where you've got X amount of days as a carrier to respond. And if you don't, there are some ramifications to the carrier if the case goes south. Same with the policy limit demand. So multi-million-dollar demands, we can average, I don't want to get into numbers, but I can say it's substantially grown since the pandemic. As far as managing and mitigating the risk effects of insurance, so everything that we've talked about on this call today, I think has been helpful. The best practice is that if you have a guideline, and I think it was Susan that was speaking to this, they follow OSHA. That's great. If somebody wants to go above and beyond OSHA and they've got a company standard, the best practice is if you have the standard, follow it. And if you follow it, document it. The turnover rate in some of the industries that we see in the commercial world is quite high. In the restaurant world, especially restaurants, hotels, so forth, we're not able to track down the employees that might have been involved in a situation or were part of the risk management at the time. And being able to have those documents to go back to is crucial in the defense of a case if we have an argument to make. As far as coverage is concerned, there are exclusions on these policies. I just talked about that under the property. We have some of the same communicable disease exclusions on the CGL policy as well. So from a commercial general liability standpoint, the carrier does have some coverage defenses that they can assert here as well. And then besides that, there are just the immunity defenses that Tony talked about in the beginning with the PrEP Act, but then also executive orders within each state. So each state has several executive orders that have been issued giving immunities to those healthcare workers or those workers in the nursing homes, assisted living, and so forth, that we plan to absolutely utilize when those claims are made against our insureds. So I want to leave time here for some questions. What can we expect from insurance post-pandemic, and how can the business prepare for these changes? We're definitely going to see a litigation uptick. We talked about that at the beginning, right? There's going to be more commercials. There's going to be challenges and creative ways to try to force the litigation on these matters and recover for those people that were damaged or injured. And I think that we're going to see a huge uptick on that. And there's just new standards of care. What you would have implemented as an industry standard last 2019 is not going to fly in 2021. So when it comes to standards of care, that's really where you have to be knowledgeable to what's new and current, and that you're following those. I just can't stress that enough. You're following those new standards of care and implementing them and documenting them in your everyday business. So with that, I will go back to Tony to run through the questions. I think you're on mute, Tony.
I was on mute. Sorry about that. Great.
That's okay.
So thanks so much for that. Yeah, I mean, we could spend at least another 2 hours talking about standards of care. I'm going to go take a look at the questions. I know Eric had at least some he wants to answer, and I think Ben. In the meantime, I just can't help myself. I had to play a little video for the group that if you, unless you've probably seen this, unless you've
I believe you have a filter turned on in the video settings. You might want to take
we're trying to. Can you hear me, Judge?
I can hear you. I think it's a filter.
It is, and I don't know how to remove it. I've got my assistant here. She's trying to, but I'm prepared to go forward with it. I'm here live. I'm not a cat.
I can see that. I think if you click the up arrow next to this.
All right. So I just wanted to show that video because I think it's just the greatest thing that has happened since COVID. That's what's going on in the court right now. Those are Zoom hearings, and that's not the most common or typical court hearing. But if you hadn't seen that, I thought I'd share it with everybody. Okay, so Eric, I know you had flagged a couple of questions to answer in the chat. Do you want to read them, or do you want me to go through them?
So I responded. I don't know if everyone could see that. But one of the questions was just on one of my. Okay, so I think the question. Let me just find it here. Okay, so from Keith Rickaball, on slide 58 of my presentation, it appeared that MERV 8 was more effective than MERV 13 filter. Were there other factors involved, or is it just a labeling error? So the short answer is that on the y-axis, it was on a logarithmic scale. So even though there's some separation from the lines, it was not as significant a difference than it may have looked. But I think the important point is that the MERV level upgrade was not really showing much of a difference between 8 and 13, whereas the standalone HEPA units were showing a very significant difference, or relative to MERV level upgrades. Both of the scenarios with standalone HEPAs were doing a much more effective job at getting the particles out of the air. But I qualify that with each test event. It's not like you can extrapolate that to every room, every scenario. I will say, though, that standalone HEPA units, at least in our data, and we've tested a lot of rooms with standalone HEPA units, they prove to be pretty effective because they're addressing kind of risk at the point source. In a lot of our test results, it's not clear that the particles are actually making it back to the filter in the HVAC system. So, but that's, it really varies, and there are a lot of viewpoints on this. I mean, kind of what we get asked to do a lot is someone is thinking about a specific solution or control, and before they pull the trigger on doing it, they want to see, is this going to have much of an impact? And so we're brought in to do that type of testing. And the MERV levels, it's across the board, it's not been always clear that, at least in our testing, that is having a huge impact. But I will, like I say, I qualify that with an Ashrae and others have been very clear that if you can upgrade, you probably should, but in some cases that's not possible. There's some technical reasons for that. So it really kind of depends. But I thought in that case, it was very surprising how little of an impact it had for that customer.
Thanks, Eric. Rebecca asked a question I think is worth maybe me trying to answer. or Megan, but she asked if we just follow OSHA standards, which are minimum standards, and there's Ashrae or CDC guidelines, which are considered, quote, the standard of care, end quote, are we liable if we don't follow those standards and people get sick in the building? And the answer to that is simply, we don't know. The person that can answer that question would ultimately be a jury, right? So, and that's what we don't want to happen. So putting together the best you can, I mean, you can imagine somebody that's a small business that doesn't have the resources for all of this type of engineering controls and testing. I mean, they're just not going to be able to do certain things, and others will. And so does that mean that certain companies are going to be held liable? It ultimately comes down to what is the definition of negligence, and that's just a breach of the standard of care. And what are others in similar situations doing? And ultimately, it's about reasonableness. And can a jury find that your conduct was reasonable, or was there some heightened expectation? But it's an excellent question. It goes to the heart of what I do, and I'm sure that Megan is interested in too. But ultimately, what we've heard today is really, I think, and Megan described it, an elevating of the standard of care. There are new technologies out there. There are new test methodologies out there. There are new engineering controls out there. And does every building owner, what about a tenant? Do tenants have duties and obligations? And I think that's going to play out in the courts in places like, Philadelphia, New York, and Chicago, and Los Angeles. These claims are going to be coming. And they're as soon as I'm sure any lawyers who are on the plaintiff side are listening to this, they're going to have clients to represent, and they're going to want to pursue certain entities for not doing everything possible. And the question ultimately is going to be answered by courts. And unfortunately, it's going to be varying based on negligence standards. All right. I think we have a couple of more good technical questions. I think Ben had identified one. Ben, do you have that handy?
Yeah, it was actually, I was thinking Susan might be the best to answer that. There was a question about the Ashrae and CDC perspective on bipolar ionization. If Susan could speak to that.
Mm-hmm.
Yes. So that's an evolving conversation. So actually, as the presentation went on, I went back to the Ashrae website just to make sure, or just to kind of see if anything had been updated. And Ashrae still is saying that they do not hold an opinion either for or against bipolar ionization. And then they also sent a note over to the CDC, which the CDC says that bipolar ionization has greatly improved since its early days with regards to not creating ozone, because we do not want any ozone. So that's where if you do want to install a bipolar ionization device, you want to make sure that has that UL rating. But the CDC says that it's also not going to give an opinion about it because it's lacking, like the device itself, like there's just not enough scientific evidence with regards to actually eliminating COVID-19 or any virus. So they're not for and they're not against. So I think everyone's kind of staying neutral. Now, if you go to GPSplasma.com, it stands for Global Plasma Systems. That's a specific manufacturer of bipolar ionization. They have lab studies and white papers that they actually tested against different viruses. And you can kind of see with their particular product what those results are if you are interested in seeing that scientific data. But they need more third-party data for the CDC to make or break a recommendation.
Thanks, Susan. I think that's important just with any technology that is being looked at, that you're looking for the resources from that vendor for documentation, as well as then, verifying, testing, and validating any technology to make sure that you understand how it works and it is working.
Great. I think we've hit the time mark. Is there any other quick answers that anybody wants to give, or are we going to run out of time here? Is there anything quick anybody wants to touch on based on the questions? Doesn't sound like it. Thanks, Amy.
Okay, thanks so much, everybody. Before we end, I just want to thank our sponsor again, RHP Risk Management, and to O'Toole Scrivo for helping to support this webinar, and to all of our speakers for preparing for it and making it happen. Remember, if you are seeking CLE credit, to please fill out the evaluation form, and we look forward to seeing you at future Perrin webinars and conferences. Thanks so much for attending today, everyone.
Thank you.
Thank you.